Okay, so here we are with the question number 2 for the week number 7. And in this question, we have a motor supplies a constant torque or twist of N equal to 200 Newton meters to the drum. So the drum is rotated actually to the clockwise direction. If the drum has a mass of 30 kilograms and the radius of gyration of the 0.35 meters, determine the speed of the 15 kilogram block A, this block, after it's going to be raises for the S value of 2 meters, starting from the rest. Neglect the mass of the cord. So you can see that the free body diagram shows the drum is going to have a diameter here, which is 0.5 meters, rotating to the clockwise direction, the twist or the torque of 200 Newton meters. The mass here is 15 kilograms going upward, and we just need to find what will be the speed of that mass. Okay, uh, the free body diagram show me that the weight is going downward. The reaction at the point O is going to be in the x and y direction, and we have the 200 Newton meters on top of it. The solution given to us by the book or suggested is to do the free body diagram of the system consisting of both the drum and the block drawn first. The only weight of the block and the constant moment to do the work. So now both the weight of the mass and the moment are doing the work. So we just need to find the energy in that case. When the block is raised for 2 meters, the drum must turn. So the theta should need to be found to be equal to 4 radian per second. Now I'll show you actually how we are going to calculate the theta value in radian. Once again, if the cable is going to turn for 2 meters around the drum, we're going to have the drum to be rotated for 4 radians. Also, the angular velocity of the drum omega is equal to v divided by 0.5. Okay, so where the v is going to be velocity of the crate. And then we can apply the equation here. We can calculate the sigma of the u from 1 to 2, the T1 and the T2, starting from the rest. So obviously the T1 is going to be equal to 0. Then we're going to find the velocity to be equal to 5.84 meter per second. Okay, so starting from rest, that means both the velocity and the omega are equal to 0 at the beginning. Now we are going to do the free body diagram. We can define that we have two bodies in one system, the drum, which is rotation about the fixed axis through the point O, and the block, which is retained in a translation. Translation is going to be work about. That's the T value, which is going to be the central forces of the total work. The total is going to be equal to 0. Then the velocity, we know this will multiply by the distance will give me kind of work as well. So the knowns are the m, the md, that's the mass, that's the moment, that's the mass of the block, that's the distance that it's being raised to. The VA1 is 0, the omega1 is 0, the KO is 0.35. We need to find the omega2 and the VA2. So once again, the equation is going to be the same equation, the energy and the work equation. And we need to start to find the T1 and then the T2. Obviously, the T1 is going to be 0 because the omega and the velocity are 0. So that's the equation. And both the velocity 1 and the omega 1 are 0, so the equation will be 0. Now we come to the other part, which is going to be the T2. Now in the T2, we can find actually we're going to have the particle of the VA2 and the omega2. The omega2 and the V2 are unknown, but we can find a relation between them because the VA is equal to the RO multiplied by the omega, which is radius of the roller multiplied by the omega of that roller. So we can say that the VA is equal to 0.5 multiplied by omega, so I can substitute here by 0.5 multiplied by the omega, and then the whole equation will be in terms of the omega. The IOD is going to be equal to the mass multiplied by the radius of gyration square. So now if I going to substitute the VA by this VA, and the IOD here by this IOD, the equation now can be written like that. And that's it. Again, to expand the solution, I know the mass, I know the KO, so I can find the value of the IOD. And here I know the radius, but I don't know what the omega is. I know the MA, so I can substitute this in. And now the equation by substituting the value is going to be this way. And then again to find the answer to say that the T2 is equal to 3.71.25 omega square or omega 2 square. Now, what's left is I found this one and I found the T2 in terms of the omega 2. Then I just need to find what will be the sigma U1 to 2. Now here, both the weight and the moment are going to make a work. We said once again that the work we're going to have here is going to be for example, the weight multiplied by the delta y. That's what we have for the mass. For this one is going to be equal to the moment multiplied by the delta theta. The moment multiplied by the delta theta. So we are going to come to the equation. These are the two works we have. And I think for this one, the weight is given. Delta y is 2, is going to go upward. So the value is going to be negative again. And the delta theta should be found. 200 for the moment. So we're going to write down the equation here. The m multiplied by the delta theta minus the w multiplied by the y2 minus the y1. Now the y2 is 2 meters, the y1 is 0, and I can find the value for that. 15, mass 9.81 g multiplied by 2 meters. Here we have 200 multiplied by 4. Now let's say how we found the theta is equal to 4. At the end, we're going to find that the work is going to be 505.7. Now, just to give you a hint about how to find the theta, and I would like you to check that yourself. Then the roller, okay? And we can know what the circumference is, because I know what the radius is. So the diameter is equal to 1 meter. The circumference is equal to pi d. Okay, now we can find that, the pi d. Now, if we know that the rope is going to be rotate as 2 meters, by making the ratio, we will find out how many pi's does the rope rotate around the whole circle. And then we can say, okay, now it's going to be equal to 4 radian. I will do that in the class. Don't worry about that. Now we come to the points to substitute everything in the equation that we have. So we are going to have the T1 is 0. The sigma U1 to 2 is equal to 505.7. And this will be equal to T2, which is 3.7125 omega 2 square. And then I can find the omega. That's it. Now the velocity is going to be equal to the omega 2 multiplied by the RO. The RO is 0.5. Then I can find that the velocity is equal to 5.83 meter per second as an answer.